Good evening, folks, and welcome to my presentation for the Pratt & Whitney 4084 engine presentation as done and requested by our professor for the aircraft propulsion class fall of 2018. I want to wish every one of you a very happy belated Thanksgiving and an amazing Merry Christmas to every one of you. Merry Christmas. No, I'm not taking up my 2 or 3 minute time. As a matter of fact, let me start my timer now so that I know to keep it within the guidelines. I chose the Pratt & Whitney 4084 engine because of just the amazing features that this engine has provided for us. See, Pratt & Whitney, but before I go further, I want to say that I use the data and the information in my paper and my presentation from the book Engines of Pratt & Whitney by Jack O'Connor, who used to be the CEO at that time, and also our textbook Aircraft Power Plants by Thomas Wilde. Good old Tom. In any case, here's a cutout of the Pratt & Whitney 4000, the 112-inch fan engine. You see, after the JT9 program, what I found out while my research was that they changed the naming convention and they moved away from the jet turbine or the JTF, the jet turbine fan, to the series. So the second series, of course, was the 2000 series, which 2037, the last two numbers in either of them, the zeros here, mean the amount of thrust that they are certified to produce at sea level on a standard day. And so the 4084 means that it can produce, or it is certified to produce, 84,000 pounds of thrust. The 2037 means it's a 2000 series or the second series engine after the JT program, and it can produce 37,000 pounds of thrust. The 112-inch fan is just the engine fan case diameter. 112 inches. That is a huge engine. That is a lot. I think it's like 1,705 pounds of air that it's pulling through right there at the N1 blades. Amazing. Kind of limited to how many slides we can do. So here's another picture. Of course, see, I have to say that I got these pictures from the website, from the internet. You know, Google is my friend. Well, not really a friend, but you know, it's an amazing thing. I think Google knows more than my wife. Don't tell her that. Anyways, here's the a beautiful picture, absolutely enormous. You can see, you know, we don't have to be scientists or aeronautical engineers to see this is 5-1. Absolutely. I think Professor Judy would beg to differ, and I'll explain the 5-1 bypass ratio at cruise. That is the amount of air that is overblown. You know, for every 1 unit of air that is punched through the high and the low pressure compressors, 5 units or 5 pounds of air is bypassed. That's why it's a high bypass turbine. To be fair, the Pratt & Whitney 4084 engine is a 2-spool. Let's see if I can go previous. 2 spools. You see, there's 1 spool and the second spool. 2-spool engine has a nominal bypass ratio of 5-1 thrust. The thrust that the 4084 engine provides is 84,000 pounds. The 4000 series ranges from 50 to 90,000 pounds thrust. This was the first engine that was ever certified from day one for ETOPS, which is the extended twin engine operations, for 180 minutes or longer. The airline that first flew this airplane, or first flew this engine, was the United Airlines Boeing 777 from London to Washington, D.C. on June 7th, 1995. It flew with the the Pratt & Whitney 4084 engine. I have a cutout over here from our book. These are the N1 blades right here, the inlet case, of course. You see, you have the cold section of the engine, the hot section of the engine, and again the cold section of the engine. To just go through it and keep it from an academic standpoint, the N1 blades, we have the stand by 1 second as I get through it. We have the low pressure compressor, the high pressure compressor, the annular combustion chamber, the high pressure turbine, and then the low pressure turbine. The specific length is the engine is 132 inches long, 112 inches of fan case diameter. The engine has 4 stages of low pressure compressor. 4 stages. 1, 2, 3, and 4. And then it has 11 stages of high pressure compressor and the stator. This is the stators and then the compressor. And they compress the engine, they compress the air to produce it into the combustion chamber where the annular combustion chamber then ignites the fuel, and then the jets coming out from the high pressure turbine, which have 2 high pressure turbine stages, and then the low pressure turbine stages, which are the 4 low pressure turbine stages for this aircraft. What is beauty about this aircraft is this airplane has 67% fewer parts because of the way it's combined. They have been the diffuser, the turbine exhaust, the diffuser, the turbine exhaust, and the intermediate case are all cast, and that reduces the amount of welding required, which increases the amount of fuel efficiency. The 3-dimensional aerofoils are also super nice. The Pratt & Whitney 4000 incorporates an active clearance control, which controls the clearance between the turbine blade tips and the turbine case. The clearance control is achieved by impinging the cold air from the fan duct to the outside of the hot turbine case. They also use the ceramic abradal outer case seals in the high pressure turbine to minimize operating clearances. This engine, from the Pratt & Whitney 2037 engine, or since the 2037 engine, uses full authority digital electronic control system, FADEC, at absolutely amazing field. Absolutely amazing thing where it controls all of the fuel scheduling, the cooling, the heating, and the go around. All of the thrust is controlled. Once the pilot initially sets it, all of the fuel scheduling is then controlled by FADEC, allowing for auto throttles to take in place. I'd like to keep it within the time limit that the professor has kept, and it's 7.5 minutes, so I'll say this. The only thing that I found online in our recent history that these engines were involved in on a mishap were the Asiana flight, where the pilots were low and slow. So for any of you that are taking flight lessons right now, please don't go red over red. Keep it wide over red, regardless of whether you're following the 3-degree glide slope or not. In any case, don't go low, don't go slow, and that's what happened. The pilots of the Asiana flight got low and slow, and then they tried to correct, and by the time they added power, or they thought that auto throttles were engaged, which they weren't, because anybody that has flown a turbine knows, hey, you disconnect that. You disconnect the autopilot, and you double click on the disconnect. It disconnects the auto throttles, and that's what happened. They thought that the engines were going to spool up, but they never did. By the time they spooled up the engines, it was too late. Again, Merry Christmas, guys. This is my first shot at recording this thing, and I'll take all the comments, and I thank you. You guys have been a great crowd. Amazing. Thanks for watching. We'll do it again next semester with a different class. Thank you, and Merry Christmas. Oh, sorry. Here's another last slide that shows the details of all of the information I already gave you guys. And that's it, folks. Thank you for watching. Thank you so very much.